Hi everyone, this lesson is on solving systems by graphing. So there's two definitions with solving systems by graphing. System of linear equations is a set of two or more linear equations containing two or more variables. Solution of a system of linear equations is with two variables. There is an ordered pair that satisfies each equation in the system. If an ordered pair is a solution, it will make both equations true. So let's do some examples working with system of linear equations and a solution of a system of linear equations. So our first example here, it says, tell whether the ordered pair is a solution to the given system. Notice I'm given an ordered pair here, 1, 3, and I'm given in this bracket, we have two equations, 2x plus y equals 5 and negative 2x plus y equals 1. What we're trying to solve here is that when we plug in 1 for x and 3 for y into each of these equations, is it going to be true? Because when we plug in x, 1 for x here and 3 for y, do we get 5? When we plug in 1 for x to the second equation and 3 for y to the 3 for y, is that going to equal 1? So what we're doing is we're substituting 1 for x, 3 for y in each equation to determine if it's true or not. So let's set this up. So my first equation, we have 2x plus y equals 5. We're substituting 1 for x and 3 for y. So we have 2 times 1 plus 3, does that equal 5? Well, 2 times 1 is 2, 2 plus 3 equals 5. So the first equation, that is true. Let's set up our second equation. We have negative 2x plus y equals 1. Substituting 1 for x, 3 for y, negative 2 times 1 plus my 3, is that going to equal 1? Well, let's see. Negative 2 times 1 is negative 2 plus 3. Does that equal 1? Yes, that is true. So is this a solution? The ordered pair 1, 3 makes both equations true, so therefore 1, 3 is the solution of the system. So to solve this, you have to first, this is your first step by solving by substitution. My final answer here is saying whether the ordered pair is makes the equations true and whether it's a solution to the system. Let's do another example very similar to the first. We're going to tell whether the ordered pair 2, negative 1 is a solution of the given system. So here again we have two equations. So I'm going to substitute 2 for x and negative 1 for y in each equation to the system. So my first one, I have x minus 2y equals 4. I'll substitute 2 for x, negative 1 for y. So we have 2 minus 2 times negative 1, and we need to determine if that equals 4. Solve by using orders of operation. 2 times negative 1 is negative 2. So we have 2 minus negative 2. Does that equal 4? Well, double negatives become a positive. So 2 plus 2, that equals 4. So that is true. Let's set up our ordered pair with our second equation with 3x plus y equals 6. Plugging in 2 for x, so 3 times 2 plus y, which is negative 1. Does that equal 6? 3 times 2 is 6 plus negative 1. That's going to equal 5, and that is false. That is not equaling 6. So the answer to this, the ordered pair 2, negative 1, makes one equation true, but not the other. So 2, negative 1 is not a solution of the system. In order for it to be a solution, it has to work with both equations in the bracket. Let's look at example number 3. It says solve the system by graphing. check your answer. So we're actually going to graph each of these equations here. They're both in the form of y equals mx plus b. So we can graph this. Remember, b is my starting point, my y-intercept, and m is representing my slope, my rise over run. So when I graph this, 2x minus 1, we start at -1, here we are, and we're going to rise 2 and go to the right 1. Rise 2, go to the right 1. I would plot a few points on the line and then connect the points to draw your straight line. When we graph our second equation, my starting point is 5, so it'd be up here. My slope is -x, so that's -1 over 1. So I'd go down 1 to the right 1, down 1 to the right, down 1 to the right. So I'll graph a few points here as well. You do need to graph because what needs to happen are both of these graphs need to cross. They need to intersect. And we see that occurs here at the value 2, 3. So it's saying, what is the system? What is the solution to this system of equations? It's going to be 2, 3. And we can check that by plugging in 2, 3 in for x and y to each equation to make sure it's true. So if I have my intersection is 2, 3, that's my solution. Let's check that because it does say check your answer. Let's set up y equals 2x minus 1. 2 times x, 2 times 2 minus 1. 2 times 2 is 4 minus 1. Does that give me 3? That is true. Let's set up the second equation with my ordered pair 2, 3 to make sure that's true as well. So we have y equals -x plus 5. So we have -2 plus 5. Does that give me 3? It sure does, so this is true as well. So we've checked, we've graphed our equations. We've checked to make sure it's true by substituting the ordered pair into each equation. So our final answer is the point 2, 3 is where the two lines intersect and is a solution of both equations. So 2, 3 is the solution of the systems, and it's just saying to check the solution you're plugging in 2 for x and 3 for y. Last example here, again we're going to graph these two equations and we're going to check our work. So again, we need to make sure both of these equations are in the form of y equals mx plus b, which they both are. So let's graph them. So here we have a starting point -1. So we start at -1. My slope is -2. So what we can do here is we can go down 2 and to the right 1, down 2 to the right 1. We can also go up 2 and to the left 1. Okay, then you connect those points. Let's graph the second equation, starting at 5. And our slope is 1, so we can rise 1, go to the right 1, or we can go down 1 to the left 1. Means the same thing. And we're going to keep graphing enough points so we can see where these two lines intersect. Notice they're going to intersect right here at this point, which is the value -2, 3. So we need to determine does this officially, we need to check our work, is what we need to do. So we came up with the solution, -2, 3 will make this true, but we need to check that. So let's substitute -2 in for x to get our y should be 3. First equation, y equals -2x minus 1. So we have -2 times -2 minus 1. -2 times -2 is 4 minus 1. Does that give me 3? Yes, that is true. Let's look at the second equation. Y equals x plus 5. Plugging in x, negative 2 for x, so we have negative 2 plus 5, which gives me 3. So this is also true. So my final answer is the solution is negative 2 comma 3, and we're going to check by plugging in 2 for x and 3 for y. So step 1 we graph. Step 2, check to make sure that solution is correct, and then writing your final answer.